Most people assume that getting less than 7 hours of sleep simply makes you feel a little tired the next day. But inside your skull, missing this critical window forces your brain to skip its essential nightly waste removal cycle, causing toxic debris to physically pile up around your cells. Welcome back to the channel. Today we are breaking down the hidden neuroscience of sleep deprivation. In our modern, always-on world, cutting your sleep down to 6 hours is often viewed as a normal sacrifice to get ahead. However, your brain views this completely differently. By the end of this video, you will understand the exact mechanics of your brain's private plumbing system, known as the glymphatic system. You will learn the specific types of cellular toxic waste that accumulate when you sleep less than 7 hours, how this debt compounds over a single week, and a clear protocol to maximize your deep rest. No overused productivity advice, just the raw, objective data on how sleep keeps your brain clean and alive. Let us dive into the science. The glymphatic system, the brain's private plumbing. To truly grasp why 7 hours is a non-negotiable biological boundary, we have to look at an extraordinary network discovered by neuroscientists called the glymphatic system. For decades, scientists wondered how the brain cleaned itself, since the rest of your body relies on the lymphatic system, which does not enter your skull. The answer turned out to be the glymphatic system, a specialized waste clearance network that acts exactly like a microscopic dishwasher for your central nervous system. Here's the catch. This system is almost completely turned off while you are awake. When you're going about your day, your brain is far too busy processing sights, sounds, and thoughts to clean up. The energy required to run your conscious mind prevents the cleaning crew from stepping in. Clinical data shows that your glymphatic clearance becomes 10 to 15 times more active the absolute moment you fall into a deep sleep. It is a highly demanding mechanical process that requires your conscious brain to completely step aside so it can turn on the high-pressure rinse cycle. Cellular toxic waste. Amyloid-Beta and tau proteins. What exactly is the glymphatic system trying to clean up while you rest? As your billions of neurons fire throughout the day, they create metabolic byproducts. Think of it like a busy restaurant kitchen. As meals are cooked, garbage naturally piles up on the counters. The two most dangerous types of waste your brain generates are called amyloid-beta and tau proteins. Under normal circumstances, these are just routine cellular leftovers. However, if these proteins are not meticulously cleared away every single night, they begin to undergo a dangerous transformation. They stick together, forming dense, microscopic clumps called plaques and tangles right between your brain cells. These plaques act like physical barriers, choking off communication between your neurons. Over years of accumulation, high concentrations of amyloid-beta and tau are the exact hallmark indicators found in severe, chronic memory loss and cognitive decline. When you choose to shortchange your sleep, you're not just losing energy. You're leaving behind a layer of toxic debris that chemically damages your brain's delicate hardware. If you're finding this honest look at neuroscience helpful, take a quick second to hit the subscribe button so you never miss our weekly breakdowns. The mechanism of cleaning, the CSF flow. How does this cleaning cycle actually work at a physical level? The fluid dynamics inside your brain during sleep are an absolute masterpiece of biology. When you slide into deep, non-REM sleep, your brain waves slow down and synchronize into large rhythmic pulses. At the exact same time, a structural miracle occurs. Your glial cells, which support your neurons, physically shrink their volume by roughly 60%. This dramatic shrinking creates wide, open channels between your brain cells. Your brain utilizes this extra space to pump a clear liquid called cerebrospinal fluid, or CSF, rapidly through the tissue. The CSF flows through your brain like a massive wave, gathering up the floating amyloid-beta and tau proteins and flushing them completely out of your skull into your body's waste disposal pathways. This intricate fluid flush requires hours of steady, unbroken sleep to reach every corner of your brain. When you cut your sleep short and log less than 7 hours, you bring this fluid wave to a sudden halt, leaving large zones of your brain completely unrinsed. Chronic sleep debt, the compounding metabolic deficit. A major trap that many people fall into is believing that sleep works like a bank account, something you can withdraw from during the week and simply repay over the weekend. It feels logical to assume that sleeping 5 hours on a weekday can be balanced out by sleeping 10 hours on Saturday. However, molecular biology tells a very different story. Sleep debt does not reset in a simple, linear way. Instead, it behaves more like a compounding deficit that builds up over time, affecting your brain and body at a deeper level. When you fail to get enough sleep on the first night, your brain's glymphatic system, the network responsible for clearing waste, does not complete its full cleaning cycle. As a result, you begin the next day with a small accumulation of metabolic waste still present in your brain. If poor sleep continues into the following nights, that waste does not disappear. Instead, new waste is added on top of what was already left behind. This creates a stacking effect, where the brain gradually becomes more burdened with toxins and byproducts. The problem is that the glymphatic system cannot simply work overtime to fix this. It has a natural speed limit based on the physical flow of cerebrospinal fluid. Even if you get a long night of sleep later, your brain cannot suddenly double its cleaning capacity to erase days of buildup. Over time, this accumulation begins to stress and inflame brain tissue. It can weaken the blood-brain barrier and make the entire cleanup process less efficient, even when you return to better sleep habits. In simple terms, one long night of sleep cannot undo a week of poor rest. True recovery requires consistent, high-quality sleep every night, allowing your brain to maintain its delicate balance without falling behind. The 7-day experiment. What happens at 6 hours of sleep? Let us look at a famous laboratory study to see exactly how quickly this compounding deficit degrades your mind. Researchers took a group of healthy adults and restricted their sleep to exactly 6 hours a night for 14 days straight. By day 7 of the experiment, the participants insisted that they felt completely fine. Their brains had adapted to the low sleep baseline, blinding them to their own decline. However, when the scientists objectively tested their cognitive speed, memory retention, and attention span, the data told a terrifying story. After just 7 days of 6 hours of sleep, the participants' brain performance had degraded to the exact same level as someone who had been forced to stay awake for 24 hours straight. Their reaction times were delayed, their focus was fractured, and their brains showed a measurable spike in circulating Amyloid-Beta. 6 hours of sleep completely crippled their mental performance, proving that your subjective feeling of tiredness is a highly inaccurate way to gauge your brain's true operational health. Conclusion: getting less than 7 hours of sleep is not a harmless lifestyle choice. It is a direct interruption of your brain's essential nightly sanitation cycle. By prioritizing this vital 7-hour window, you allow your glymphatic system to flush out toxic proteins, protect your memory pathways, and keep your cognitive engine running at maximum efficiency. How many hours of sleep did you get last night? Let me know your numbers in the comments below. If you found this data-backed neuroscience breakdown helpful, please give this video a thumbs up and subscribe to the channel. We share clear, unhyped health videos every single week to help you master your biology. Next week, we are going to look closely at the data of why the first 90 minutes of sleep are the most critical for your recovery. Thank you so much for watching, and I will see you in the next video.